Right, proceeding. Properties of the definite integrals. Here we have 7 properties. Number 1, the integral from a to b f of x dx is the negative of the integral b to a f of x dx. That is, reversing the bounds will make a negative sign appears on the integral. The second one, the integral a to a f of x dx equals 0. That means the area under the curve between a point and itself is 0. So there's no area to calculate. Number 3, the integral a to b of f of x plus or minus g of x dx. This is the distribution property. The integral can be distributed on both functions. This is a to b f of x dx plus minus the integral a to b g of x dx. The fourth property is the integral of a constant multiplied by the function on the bounds a to b. Well, see, here's a constant. This is equal to the constant itself multiplied by the integral a to b f of x dx. That is, we can kick the constant out of the integral, where c equals constant. Number 5, the integral a to c f of x dx plus the integral c to b f of x dx can be combined to give a to b f of x dx, where here we have a, c, b. That is, c is somewhere between a and b, and therefore we can take a to c plus c to b as a one integral from a to b. Number 6, if f of x is greater than or equal g of x, then the integral a to b f of x dx will be greater than the integral g of x dx. So if two functions have the areas under them, then the higher integral, or the one of larger value, is expected to have more area under it than the lower function or lower curve. Number 7, if we have the function is confined between two values, a small value and a big value, that are corresponding for x between a and b, then let's take a graph to show this before then we put this in the equation. So here I have the functions, or the function. This is x, this is f of x, and the function shows up like this. So if I take the interval between a and b, In this case, if we have a value, an upper value here, let's say capital M, and the lower value, say here small m, then what we are saying here is that the big rectangles area here, which is M, I will shade it like this, will be greater than the area under the curve itself, which I'm shading in here, and these two will both be greater than the area under this small m value. Therefore, we can express this as the area of the smallest slab here, which is m small times b minus a. B minus a is the width, is less than or equal the area under the function, which is the integral a to b f of x dx, and this is less than m capital times b minus a. So this is the seventh property that we may use here for the this function. Of course, this area under the curve is given by the integral of the function from a to b. Now, having this said, we may apply this to the following example. Estimate the integral 0 to 1 e to the minus x squared dx, where here we may use the graph to see how this function looks like. So this function starts from 1 and goes decaying like this. If you take the interval from 0 to 1, then this value here is e to the negative 1, let's call it small m, and the 1 here is capital M. So we have three areas now.